57% say choice B, which is incorrect. Option 2 is incorrect. 43% said option 1, which is correct. Let's try to run it. Let's see if it actually runs. Run Aync JS. Hi, welcome to loop A. And let's wait. The for loop is more than 15 seconds. This is a very long for loop. There you go. Expensive operations are expensive first. Click the button gets created. This gets first, which means option 1 was correct. Option 2 is I totally get why you might thought option 2 because you said and clearly says after 1 second this would run. So after 1 second this would run. Why did this not run after 1 second? Because the thread wasn't free. I repeat. Tell me, let's say you start the washing machine and you are running a thread. Here's an experiment. Example. In the real world, you start the washing machine on one side. Why? You go to another room and you are running on a thread. This is a CPU intensive task. It requires your constant play. It requires you to constantly keep on running. This is a IO intensive task. This is you have delegated the task to someone else is washing. Now let's say after 10 minutes this starts to after 10 minutes this starts to run. Tell you okay, I finished washing the clothes. And let's say you started 30 minutes. You decided he asked me to run 30 minutes. So will you stop your execution? Will you stop your CPU intensive task and move on to the washing machine? No. You will keep running for 30 minutes. Even though this finished after 10 minutes, you will keep running for 30 minutes. After 30 minutes you will do it. So when you are doing the CPU intensive task, first that will finish. Only when you get from here, will you look at all the pending things in the callback queue, which takes me to this loop architecture that I will show you. It has a callback queue at the bottom. Everything else. This is a queue of things that are done. This is the treadmill telling you, if I am done. But you won't get it easy. It stays in the queue. Whenever you are done running for 30 minutes, you will try the same experiment here. There are 4 sections over here. Let me give you a brief of what these 4 sections are. That will make it much easier to understand why this code runs the way it does. The call stack. This means the thing that is currently executing, which is abhi chal rahi hai. If console.log high happens, high gets pushed onto the console.log high gets pushed onto the call stack. Call stack means the current stack of things that are being called. And it becomes a little more complicated as we have functions. We'll come to what this is if you want to watch video. What is the call stack over there? But here, it basically means we can line what line of code is on right now. If console.log high is the first line, it will get pushed to the call stack. Set time is the second line. Currently executing, which is abhi chal rahi hai. If console.log high happens, high gets pushed onto the console.log high gets pushed onto the call stack. Call stack is the current stack of things that are being called. And it becomes a little more complicated as functions. We'll come to what this is if you want to watch video. What is the call stack over there? But here, it basically means we can line what line of code is on right now. Console.log high is the first line, it will get pushed to the call stack. Set time is the second line. And it will publish something on web. If console.log high gets pushed on. Here's something more complicated. Let's do all these first. Let's make everything simple. Console.log high, console.log loop, console.log. And then let me introduce a formula for like 0, C++, let's see 0, something like this. Let's say I have no asynchronous operations. I have all synchronous operations. There is no set timeout here. There is no read file here. When that happens, when this section becomes relevant, this callback becomes relevant, this event becomes relevant. Only the call stack is the important. If I am this.
I don't understand why this fucking shit is so lagging. I don't understand why this shit is so lagging. Settings. Music is fixed.
All of these are lines of code that basically you can push off the call stack. This is the best. Basically, I can C++. All of these are one by one executing on the call stack. Then eventually console.log C happens. Let's wait for it. Oh, it push out. We run. Console.log happened. Console.log this happened. 10 iterations of code will run. Let's wait for 10 iterations to happen. 3. Notice nothing happens here. Nothing happens here. Again, यहाँ पे actually C++ also run, I++ also run, visualization is the best, which is why you only see one thing. Last में this ran. Call stack is what the CPU is doing right now. What are the CPU intensive tasks that are running. If the call stack is busy in a for loop, अगर ये कुछ काम कर रहा है, then whatever is happening here will have to wait. I repeat, ये जो second section है, this web API section. This is all the asynchronous tasks that you have offloaded to the web APIs. What does web APIs mean? Basically means whatever the browser provides you. There are some things that JavaScript provides you. There are some things that the browser provides you. Believe it or not, this set timeout function was never part of JavaScript. JavaScript wasn't ever supposed to support this. This is something that the browser provides you on top. In this case, this is something that Node.js provides you on top. If you do a fs.read file, this is something that Node.js provides you on top of the basic JavaScript specification. The web API section, whatever you see over here, are the extra asynchronous calls that the browser provides you. Set timeout is one such call. If I put set timeout over here now, let me remove these set timeout and define the timeout function. Let me change this execution to look something like this. I first log something, define the function, start an asynchronous operation. Start it. Delegate it to someone else. Delegate it to web APIs. This is going to be run / handled by someone else. My washing machine is independently running while I move on to an expensive operation. I start running on the treadmill. While I'm running this expensive operation, and finally logging it. Doesn't matter if 10 seconds have passed. Doesn't matter if the washing machine is done. I will not go to the washing machine and check on it until I've finished my task. So if I actually run this, you will see this in action. High gets put here, set time out is put here. The washing machine is running independently. The washing machine is running independently, just taking sweet time. While I am busy running this CPU intensive task. The washing machine is done. It is able to push things onto a queue. I don't pick it up. I am busy running. After I'm done, I pick it up from the queue and I execute it. Let's see this one more time. Let me increase the number of iterations to be 20. Control of high gets executed, set timeout line gets executed. When the set timeout line gets executed, web API starts a timer. It starts something for 10 seconds. When 10 seconds have succeeded, it doesn't tell me directly if I go there later. It only has the power to push it onto a queue. And whenever I become free from this CPU intensive task, which I'm running right now, you can see the call stack is busy. If the call stack is busy, it will not be able to pick things from here. Only when this becomes free, we'll be able to pull things from here and run this. Now that it became free, pull it and run it. Which is fine. Even though you write set timeout 100,000 here, doesn't mean it will 100% run after 1 second. If the CPU becomes busy like it did over here, then it might run after 10 seconds also. It might run after 20 seconds also. JavaScript cannot guarantee that. You are telling, okay, 1 second after 1 second, push it on the callback queue. But whether or not it gets cleared from the callback queue depends on if the thread is idle. Now, if you're doing such an expensive operation, then of course the thread is not idle. It is not able to pull elements from here. It is not able to execute your callback function. Let's do a poll and see how many understood this in the first go. If you understand this, then tomorrow will still be hard, but not as hard because tomorrow we understand promises. Oh, we understand this very well. 91%. Great. If you understand this, so let me give you an assignment. Think of so maybe if you understand by tomorrow, definitely try to read about promises. Try to at least Google ChatGPT. Because if you go through tomorrow, right, then life is going to be smooth for you. If you don't understand tomorrow, then you will be stuck in this, promises for a long time. So try googling what I mean when I write this before tomorrow. Try to do some of these by tomorrow, so that tomorrow also you're able to go through. If tomorrow you're able to go through, इसके बाद we'll start simple full stack stuff. Creating HTTP is very simple. I can tell you. इसके बाद no roadblock will come until you reach React. So please by tomorrow try to finish this. And we'll go from there. You will be stuck in this, think of so maybe if you don't understand by tomorrow, definitely try to read about promises. Try to at least Google ChatGPT. Because if you go through tomorrow, right, then life is going to be smooth for you. If you don't understand tomorrow, then you will be stuck in this, promises asynchronous for a long time. So try googling what I mean when I write this before tomorrow. Try to do some of these by tomorrow, so that tomorrow also you're able to go through. If tomorrow you're able to go through, इसके बाद we will start simple full stack stuff, creating HTTP, so very simple stuff. I can tell you. इसके बाद no roadblocker will come until you reach React. So please by tomorrow try to finish this, and we'll go from there. Great, 92% understands this. I'm still here for doubts, but I think that's all I had for today's class. If you have any more questions, I'm sticking around here for the next 20 minutes. So let me look at Q&A for a bit and try to answer any questions you might have. Obviously the class is done. Thank you everyone for joining. Tomorrow we will understand promises and async await, and then we'll go from there. All right. Here we want to write the same code read file sync, only done gets printed and the callback contents does not get printed. Why? Okay, if you write the same code with read file sync, only done gets printed, the callback function content does not get printed. Oh, const fs equal to require fs, const contents equal to fs dot read file sync a.txt utf8 console.log contents. The read file sync function doesn't expect a third argument. If you want, you can pass it as many arguments that you want, but it doesn't expect anything after these two. It is synchronous. It will return you the contents right here, so you can log it. You don't need to pass a third function. If you do, that function will get ignored, which is why nothing gets logged for you. Error would be an object type. Why only? And why only? And why object only? Error. Let's see what the type of object is. Read file, callback function, callback error comma data, console.log, type of data. Sorry, error. Node index.js. Let me change this to something else. The type is indeed an object. What's your question? Error would be the object type. And why only object type? Anytime you're receiving errors, you might say here it should be a string. Error can only be, whatever. There was an error reading this file, but a lot of times you need associated data with the error. You need the error message. You also need the error, status. Let's say 201 file not found. You might need some extra data, metadata, permission denied. So error is a good idea for it to be a complex object, so that you can extract more details on what the error was versus it being just a string. And again, this doesn't depend on you. This depends on whoever has written the read file function. If they want to return you an error object, they will call back with an error object. Should I use NeoVim as a developer? First, learn Lua. If you don't want to do it, learn Lua. Create your own config. Go from there. Oh, what happens if I change the arguments? What do you think happens? Data, error. Callback still gets called with first argument as error, second argument as data. So just because you change the names here, let's say I define function subtract a comma b, return a minus b. Let's say I write function like this. Now if I flip the arguments b comma a, what happens? I'm now subtracting it the other way. So do you understand this? अगर आपने a और b को change कर दिया, your function is broken now. You are not subtracting first argument minus second argument. You are now doing second argument minus first argument. So if you change the names from whatever this to data and this to error, यहाँ पे फिर भी error ही आएगा. Now this data variable of yours will contain the error. This error variable of yours will contain the data. So that is what will happen if you flip the arguments. Who is passing the value of print arguments, error arguments? The person who has written this function. The person who wrote the read file function is calling callback with the right set of arguments. What was happening on replet over here? If I go to replet, who was calling sum? It was the do operation function, right? The do operation function, you gave it the function signature, it was calling the function signature with some arguments. And similarly, here to the read file function, you gave a function signature, and inside the read file function, if you read through it, eventually over here, if you look at the function signature of read file, look at how it actually reads the file. Inside this read file function, callback gets called with error and then the actual data. So for that, you have to look at the implementation of this function and how it does it. Similar to how in our do operation key implementation, I call op with a comma b. So it depends on who wrote this function. They are calling this function, they can call it with whatever you want. Does functional argument and callback mean the same thing? No, technically not. Callback is more relevant as a term if it is an asynchronous function. If it is a synchronous function, then it's not the best thing in the world to call it a callback. It's just a functional argument. So you can think of this as the difference between a functional argument and a callback. Whenever it is being called asynchronously, which means after some time, after some ticks, then it's a callback. Otherwise, it's a this thing. Is it necessary to create interface for Node.js to taking input? What does that mean? Are you asking, do you need to, when you're doing node index.js, you need to wait for user input? You cannot, it depends on you if that's a question. Flutter dev here. As per my knowledge, async code is awaited and the execution is stopped from moving forward till the code is completed. Is it different from JavaScript? I would assume it is the same in every language. I would assume Rust has concept of async await, works similar to this. I would assume the same thing happens in Dart. When I did a fs.read file here, it is being run in the background asynchronously by someone, and they will eventually call this callback. And I can move on to do other things. However, okay, maybe this is what happens in Flutter. We will discuss this tomorrow. But if I write something like this, read file. Wait, this is probably what you do in Flutter. Const data equal to this, and console.log. Done. So if you do this, then done will not get called. But that doesn't mean that the thread is busy waiting here. What does busy waiting mean? The thread here infinitely run. It's not waiting here infinitely. The thread does other things. This code that we've written over here is similar to this fs.read file, whatever a.txt, utf8, you get the idea, callback. And inside the callback function, you have console.log. Done. So this is probably what happens in Flutter when you're awaiting. It is similar to you writing code like this. Whenever the callback gets called, done is written inside it. Versus if you're writing it in the async await format, then it means the same thing. That doesn't mean the thread is stuck here. That means the thread is doing other things and will eventually come back to this done. Similar to how thread is doing other things and will eventually come back to this done. Link to the slides is on projects.hidexteps.com. Pasting it in chat. For doubts in Discord, you have a dedicated web dev group. Ask it there. Monday interview, I don't think you can do much by Monday, but try it out. I mean, just breathe in, breathe out. Nothing you can do in a day to prepare for an interview. Standard interview question to prepare. Is there a way to make set timeout asynchronous? What do you think? It's a good question. How can you make set timeout synchronous? You can do something like this, right? I'm going to write something. Function set timeout sync. While one, let start time equal to. I'm writing some extra things here which you might not know. Let current time equal to new date. If current time dot get time minus start time dot get time is greater than 1000, then break out of this. Set timeout sync 1000, sorry, timeout, console.log. So this is how you can make set timeout synchronous. What do you need to do if it needs to be synchronous? It needs to busy wait. It needs to keep the thread very busy. You are doing an expensive operation. A CPU intensive operation is happening. Then it will keep on running this infinite loop. Then it will check. What time ho gaya? Has 1 second passed since we started? We started over here. Infinitely keeps on checking. Has 1 second passed? When the 1 second has passed, it breaks out of the loop. Then console.log hide happens. If I run node index.js, you will see after 1 second hide happens because now my set timeout is synchronous. It is not asynchronous. And how is it synchronous? I have written an infinite loop where it is checking second ho gaya. After 1 second has succeeded, it makes the thread free. If you don't understand this, is fine. Site tour. Sync takes 8 seconds and async only 1, but sync messages get printed first and async at last. While in between, console gets printed. Post a screenshot web dev doubts channel. Which one? Web dev 1, web dev 2. I'm sorry, take it from there, but not take it from there. You post it in the web dev thing. Is it necessary to create and understand the question? I understood the async code. What an async code is. But what makes a function async? Like you call back print, which makes it asynchronous. How? Good question. What makes a function asynchronous? That's a good question. Anything that requires these browser APIs, anything that you offload to someone else, anything that is IO intensive is asynchronous. Or anything you build on top of it. Anything you build on top of it. But if I write some code that read a function read from 2 files. If I write a function like this, then this is also an asynchronous function, file 1, file 2, because it will first read through the first file, which will take, which is asynchronous, then read through second file, then return the response. So, whatever, file 1 response, file 2 response. So, either all the functions that are natively asynchronous, which, is the read file function, the set timeout function, the fetch function we'll discuss eventually, database calls, we'll discuss eventually, either functions that are natively asynchronous, or any function that you define on your own that depends on these natively asynchronous functions is also asynchronous. So, this function is also asynchronous, but we'll get to this tomorrow when we learn about the async await syntax. Can you create event loop once? Yes. So event loop, as the name suggests, is a loop that runs whenever the call stack becomes empty. The goal of this loop is to pull the first item from this callback queue and push it onto the stack so that the stack can start executing it. If this inside this was also a let's say very expensive operation, then what will happen? If I run this, let me make this 2. This gets logged, then the timer starts, then the CPU intensive task is running. This is done. Now the call stack is free. Since the call stack is free, the event loop can pull things from the callback queue and start these. Now this started another expensive operation, and hence that expensive operation will keep on running. If something else had been pushed onto the callback queue, it would have to wait until the call stack became empty. When it would become empty, more things would have been pulled. So something like that would happen. All right. Now let me just open chat if you had more questions, so that it's easier for me to look at them. Alright, can you paste the questions in chat? Alright. I only have basic knowledge of results. I don't know whether to write from you or not. Can I learn Web 2? You sort of can, but until React you should learn. The first 10 to 12 weeks, don't ignore. Do full stack for the first 10 to 12 weeks, ignore after that. Does all async functions have callback? Yes. But there are other ways to write async functions, which we will discuss tomorrow. But under the hood, they all use either what are called promises or callbacks. So yes, most async functions either are promisified, something we'll discuss tomorrow, or they have callbacks. And it's easier to learn more about async for tomorrow's class. It's a good question. Promises, key videos, if you can go through, from wherever doesn't matter, would be nice. Promises are very hard to digest. I don't have resources as such. I just learned it by, coding a lot. Like, I don't have a resource on top of my head, but yeah, before tomorrow, promises, try to understand. Promises, more specifically, writing a promise. The assignment that I gave today, writing a promise. If you can understand this, then you'll be sorted tomorrow. When will we learn about Git and GitHub? I'll post an offline videos, like simple stuff. Or we can do it in a week. I like, but usually GitHub usually we cover an offline video, take an hour to finish everything you need. Again, how do we control the callback queue in my application to use those async functions as we normally do with sync functions? How do we control the callback queue in an application to use those async functions as we normally do with sync functions? I don't understand the question. How do you control the callback queue? You don't control the callback queue. You offload a bunch of tasks here. Whenever the tasks are done, they are pushed to the callback queue. What do you mean by control the callback queue? I will open the chat one more time. Can you elaborate a bit on your question? Maybe put it in a Notion doc with more, elaborate what you mean here. One suggestion. Please add capacitor JS module so we can understand Next.js to make Android apps with Next. Is this okay? It's by Iconic, yeah. Why not just do React Native? I mean, it's good if you want to do cover this, but now React Native is fairly easy to understand. I've done this Ionic framework in the past. Let me know, like, convince me if it's a better thing to do over React Native, and you're happy to do it. I'd rather just do React Native. Fetch is already promisified. Yeah, I think so. I think fetch is already promisified. I think it is promisified. Hey, I have a doubt. If the delay is 6 seconds and 6 seconds after completion execution of the loop, it will take 3-4 seconds. As 2-3 seconds are done while executing the loop. If the delay time is 6 seconds and it will take 6 seconds, no, it will not take 6 seconds after the completion of the loop. That is a good question. As you can see, they run independently. If you open latent flip, this expensive operation runs independently, and the for loop runs independently. So as you can see, even though an expensive operation is running here, the clock is also running parallelly. This is running on a separate thread parallelly. This is running here. So it'll not first wait for 6 seconds and then wait for another 5 seconds. This is waiting in the callback queue now. Whenever this becomes free after 6 seconds, it gets pushed over here. Good question. How would you know if do I need to use async function code or when I use synchronous? So for anything that requires IO intensive tasks, you should use asynchronous code. If you know you are going to hit a database, if you know you are going to read a file, if you know you have to use a set timeout, use asynchronous code. Requires IO intensive tasks, you should use asynchronous code. If you know you are going to hit a database, if you know you are going to read a file, if you know you have to use a set timeout, use asynchronous code. Don't use synchronous code. How do I improve performance of my code to prevent blocking the main thread from while handling long tasks like loop, for example, without dealing other asynchronous operations? So you can't unfortunately do that in JavaScript without getting fancy. JavaScript is a single threaded language, so unfortunately you have a single thread. If you have a CPU intensive task that is running, that has occupied the thread, there is nothing you can do. All the asynchronous tasks have to wait. What you can do is spawn worker threads, which we can get to if you want, or you can start Node.js using this thing called the cluster module. Basically start a bunch of Node.js processes so that you can have multiple processes, one doing one task, other doing another task. Too fancy of a thing to talk about right now. Right now, no, it is JavaScript is single threaded. If you had 10 async operations, they're all waiting in the callback queue. They will keep waiting in the callback queue until your CPU intensive task is done. Answer that. What is the difference between import and module? They're just, import is a more newer way for you to require other files. It was introduced in some ECMAScript. If you've heard of ECMAScript, if you understand it a little bit, JavaScript is just an implementation. Node.js is just an implementation of JavaScript. Every browser has its own compiler of JavaScript, but there is a committee that decides that JavaScript may syntax hoga. This will be the syntax in JavaScript, and it keeps on improving. So require was the old way to import modules. Import, the thing that we've written over here, import and export, are the more modern way to import and export modules. Harkya, do we answer that you cannot control the callback queue? Can you write asynchronous code from scratch? That is a great question, and I think the answer is no. Can you write asynchronous code? You're saying without using any of these web APIs? Unless you can get access to libuv and spawn. I don't know. Maybe there's a way. I've never done it. I've never seen it being done. Whenever you write asynchronous code, you use other asynchronous functions that this web API section provides you. Can you write one from scratch? Is a great question, and I don't know. Maybe just technically the answer is yes, but I've never seen it being done. You write your own asynchronous function from scratch. That's a great question. I'll probably Google after the class. Fetch is already promisified. That is correct. How do we control callback? So that people post the same question twice. But CPU has many cores. Does this mean the for loop takes all CPU cores? And if not, cannot set timeout use the remaining cores to execute? Yes. If this was Golang, this was Rust, you would have been able to do what you're saying. But JavaScript is single threaded. We discussed this last week. Even if you have 10 different cores, JavaScript will not use those 10 different cores. It will keep on running that for loop on the single, call stack. It has a single call stack, right? It doesn't have multiple call stacks. It cannot execute one thing here and one thing another call stack. So unfortunately, JavaScript will not be able to do it. If you use a different language, then yes, you can, spawn threads. If you've ever used Golang, Rust, C++, Java, you can spawn threads and use all the 10 cores of your machine. But JavaScript cannot. JavaScript is single threaded by nature. There are ways to parallelize, create worker threads, a bunch of things that will allow you to use other cores. But when you're writing standard JS code, you have a single call stack, which means everything is running on by one. Can you explain more about the error? It is just something that whoever wrote FS module calls your function with. Agar meri washing machine hai, there is a washing machine there. It depends on the developer of the washing machine, whether it should do a TT or a TU. Similarly, whenever you give the read file function, see, whenever you call fs dot, read file utf8 comma callback. It depends on whoever has written the read file function how they call your function. You know, the author of the read file function said कि यार मैं तो पहले तुम्हें error दूंगा, I will first give you the error, then give you the data. So over here in your logic, you should first check if error exists. Then you should log something like, you know, file not found, or, you know, error while fetching file. And then if there is no error, then you should log the data. So this is how you should write code. You know, this is what the error argument means. It just means that whoever was the maintainer of this specific read file function, whoever is the author of this, calls your callback function. You give it a signature, they will call it in this format. Formalize cohort 3 and continuing to journal. Great, beautiful. Cohort 3 kernel. What does kernel mean? Like journal, a continuum journal of cohort 3. Link to slides, recorded videos, video 1, video 2. What happened? Stuff to do. Harkirat, explore this. Great. This is great. We should bring this in house, sir. Aditya loves jujitsu@gmail.com. Let's talk on Twitter. Ping me on Twitter. And let's formalize this and put this somewhere. What if we are doing 3 to 4 console log statements below extensive tasks? Then first those 4 log statements will run, then your callback will run. जब तक आपका CPU free नहीं होता, whenever until your call stack is empty, nothing will get pulled from here. So, you know, first all of those logs will run, then this will get pulled. How do we actually define someone process? So the clone looks pretty good. Oh, the whole file, oh, that looks good. Is it responsive though? Isn't responsive, but that is fine. Would have been nice for extra. You haven't learned it yet, but it's pretty good. The full website, very good. What if we run 2 async functions and the second async function completes first? So the second async function will be able to put things on the callback queue first. If I have a set timeout of 10 seconds and उसके बाद a set timeout of 1 second, then पहले this will be able to reach the callback queue, then this will reach the callback queue. So this will execute first, this will execute second. If I run this, even though callback queue में पहले ये गया, sorry, web APIs में first this went, but in the callback queue first this guy went. So first this guy will get pulled, then the 10 seconds guy will get pulled. Option 1 is correct, and the async. Then what is the use of async set timeout in this one? Okay, it's single threaded. If you want set timeout before, expensive how? If option 1 is correct, okay, what were the options? I totally forgot. Then what is the use of async set timeout in this one? Okay, it is single threaded. If I want set timeout